So in this video, we're going to do some practice problems on graphical displays. So you might have heard a cliche saying, a picture is worth 1,000 words. Sometimes a graph can tell you a lot of information much quicker than what a table can. And maybe the table, it might be like a long table of values of x and y, or t, usually time, and some value that depends on the time. And in a table, you can't really see trends, but in a graph, you can see the trend quite easily sometimes, or maybe there's no trend. So in a graphical form, you can see that trend if it exists or not. And similarly, if you want to graph, you have like a set of data that's a distribution. So like, for example, you took a poll and there's a certain amount that chose one option, and a certain amount that chose another option, and another certain amount that chose option 3. You want to show the distribution of like how many people chose each one, or voted, let's say it's a candidate, voted for each one. Then you can show it like with a bar graph, for example. Or if you took measurements of people's height or something like that, you might want to show a histogram or a box plot. Bar and whisker graph, that's what sometimes it's called also. Something like that. So a graph is just a useful way to represent information a lot of the time. Okay. Sometimes graphs, if you overcomplicate it, it might make it harder to interpret actually. So it really depends on how you, as the person displaying the information, does it. But anyway, let's go through these problems. So we're going to practice on a line graph and a histogram. So this one says questions 1 through 3 refer to the following. The line graph shows the enrollment for College R between 1950 and 2000. Okay, so number 1 says, according to the graph above, College R showed the greatest change in enrollment between which decades? So go ahead and try to pick the right answer first. So you want to pick the value with the greatest change in the y-axis because the enrollment is in the y-axis. Or you could pick the one with the steepest slope. All right. So if we just look at the slopes, it looks like this one's the steepest. So that's the answer. Between 1960 and 1970. The delta, or the change in y, is like, what is that, 1.5-ish? Nothing is bigger than that if you actually look at all the other choices. But the quickest way, see, this is where the graph can tell you information very quickly, just look at a slope instead of going to calculate the change in y in each one. Okay, what is the average rate of increase in enrollment per decade between 1950 and 2000? So go ahead and try this one. So let me shift back up here if we need to. Average rate of increase in enrollment between 1950 and 2000. Okay. Average rate of increase, or the average rate of change, hopefully you remember how to do that. It's just the change in y over the change in x between those 2 points. So at 2000, it was enrollment of 7,000, so I'm just going to write 7. Okay. And then 1950, the enrollment was 4,000. I guess let me write in thousands. Okay. So this is 3,000 over 50, which is 600. 2 is B. So average rate of increase is just a slope between the 2 points. Okay. If enrollment increases by approximately the same percentage between 2000 and 2010 as it decreased between 1950 and 1960, what is the expected enrollment in 2010? So go ahead and try this one. Okay, so between 1950 and 1960, how much did it decrease? It decreased by 500 because this is in thousands. So half a thousand, 500. Enrollment decreased by 500, but it's asking for percentage. Enrollment increases by approximately the same percentage between these 2 decades as a decrease between these 2 decades. So what's the percent decrease here? Remember how to find percent change? So the change is 500. All right. And we reference the initial value, so 4,000. So what is that? If we cancel out some zeros, that'll be 1/8. Okay? So that is 12.5%. Okay? So from here to here, it decreased by 12.5%. Now it's saying from here to here, it would increase, so the next decade, it would increase by 12.5%. So it's 7,000 times 1.125, because it's increased by that much. Okay, and if you put that into your calculator, that is 7875. Answer's D. Okay, why is it times 1.125? Well, it's 7,000 plus 7,000 times 12.5%, or 0.125. So you can just do it quicker by 1.125, because it's 7,000 plus 7,000 times 0.0125. You can factor out the 7,000. Okay, now this histogram one. The histogram above shows the distribution of the number of triples hit by 30 Major League Baseball teams in a certain year, which the following could be the median number of triples represented in the histogram. So go ahead and try to solve this one. Okay, so median is the middle number. Okay, so between 10 and 20, there were 3. Here there's 2. Okay, so basically we want to find the middle. So we don't know the exact numbers. This is a histogram. But we can kind of guesstimate where it will fall, okay? So how many are there total? There's 30. So before I go back to counting, there's 30. So you want to find the 15th and the 16th, okay? The median would be the average. Okay, that's how we find the median. We cross things out until we get to the middle. There's an even number, so it'll be the average of the middle two. Okay, so now let's start counting again. We want the 15th. So here there's 3, and then here there's 14. So it'll be somewhere here between 20 and 30. And similarly, the 16th will be the one right after, right? So there is 17 from here to here. Okay, because 3 plus 14 is 17. So 15 and 16 would be in between 20 and 30. So the median has to be B, because both the 15th and 16th value are between 20 and 30. If you take the average of them, it has to be between 20 and 30 still. It cannot be even smaller, because they're already bigger than 20, and it cannot be bigger than 30, because they're already both smaller than 30. Okay? And that's it. This was a quick video, and hopefully these weren't too bad. Just trying to interpret the graph, all right? So if you need more practice, then feel free to look up more practice problems on the internet. I'm sure there's plenty there, all right? As always, if you found this helpful, please like and subscribe.